So this is my rolling robot. It's basically a two-wheeled robot based on the AVR platform, and it has an IMU on it with gyroscopes and accelerometers and such. And it also has a rangefinder, which is on the front. And you can see it's dynamically balanced because it's two wheels, and it has, if it wasn't balanced, you can see how it speeds up and slows down. If it wasn't balanced like that, it would just do lots of somersaults on the ground. But based on the rangefinder, it's able to sort of find its way around. I'll give it a go over here and we'll see what happens. Here we go. See, it kind of like discovered these out. I'm going to stand here and try and block it so it doesn't. Nope, so there we go. Otherwise it's going to end up in the bathroom and then it's going to get stuck. Now it has problems if it sees something from a really glancing angle like that. We'll see. And then it's, the sensor gets turned up in the air, and then it doesn't really know what's going on. But you can see it kind of navigated around this space and does a reasonable job. But then there are a couple of failure modes. There's one when it hits something that it can't really see, like that. So it has to, because it has such a limited field of view. And then the next problem is that it can't tell if it's about to run over something that's low. Like, for example, oh, actually I didn't do too badly there. If there's a carpet or a wire or something on the ground that's kind of blocking it, then it will actually fail to get over there and get stuck instead. Here it's kind of like gonna, I think, run off into the bathroom, but we'll see. Nope, heading back again. Yeah, so I'm trying to do a lot more with the algorithms, but this was really just a simple test. Now the way this is working is it's actually doing turns, and the tightness of the turns is sort of proportional to the distance that it sees in front of it. So like if it has a large distance in front of it, then it will actually go more straight, and then if it sees something close to, then it will actually stop the forward motion and it will just do rotations. But the rotations are kind of random, so it can turn in different directions. So it does navigate quite well through these environments, even though it has these failure modes. So I mean, really the approach going forward is to try to make it more sensitive to whether it's crashed into something, and then like deciding like that, for example. Now here it's crashed into something and the sensor's pointing up, so like if I actually put my hand there, it will actually realise that that's actually not somewhere it should go, and compensate. So I'm going to stop the video there, but you get a general idea. Bye bye.